Hello everyone. So my name is Sachin Garg and I'll be your math tutor for today's session. So in today's session we are going to talk about nature of roots, right, of quadratic equation. As you know, in previous session we have started about the quadratic equation, right? So now before going further to the nature of roots, let us discuss about some concepts of the previous session that we have already studied, right? So now let us see what is a general form of a quadratic equation. As we know that the general form of a quadratic equation is ax square plus bx plus c equals to 0, where a cannot be 0. Now students, you just tell me why a cannot be 0. Yes, I have already told you the reason yesterday. Huh? Okay, so now here a cannot be 0 because if a is 0, x square will become 0. So it will not be a quadratic equation. Now here a, b and c are real numbers, right? Is called a quadratic equation. Getting in a simple form of quadratic equation is general form ax square plus bx plus c equals to 0. Now if alpha is one of the root of this equation, right? Now what do you mean by root? Yesterday we have discussed that root means that the value of alpha, right, will satisfy the equation, right? Then this alpha is going to satisfy this equation, right? If we put alpha in place of x, that is a alpha square plus b alpha plus c, that will be equals to 0, right? Now I hope you remember about Dharacharya's formula, right? In yesterday's class we have discussed about Dharacharya's formula. Now the quantity d equals to b square minus 4ac is called the discriminant of the quadratic equation, right? Now here the quadratic equation I am talking about is the general form of the quadratic equation, that is ax square plus bx plus c equals to 0, right? Now by Dharacharya formula we got two roots, right? Now the roots of the quadratic equation generally denoted by alpha and beta are minus b plus minus root of d upon 2a. Now one root is with plus, right? Other root is with minus, right? Now from where do we get these roots? From Dharacharya's formula, and that formula is derived using completing square method. I hope this is clear. Come on, give me a yes. Okay, great. So now let us proceed further to today's session, that is all about nature of roots, right? Now the nature of roots of a quadratic equation, see very carefully, without finding the roots even we can tell that how the roots will be, right? Whether they are real, whether they are not real, whether they are equal, right? Now that totally depends upon discriminant, right? That totally depends upon discriminant. So now how they are dependent on discriminant, see very carefully. It is the number being used to describe the nature of roots of a quadratic equation. Now, what is discriminant d? That we have already known that d is equals to b square minus 4ac. Now, I hope you remember what is a, b, and c over here. B is coefficient of x, right? A is coefficient of x square and c is the constant term. Now, this is considered b square minus 4ac. We take ABC when they are in standard form, right? Provided the equation is in standard form. Now, let us talk about the nature of roots if d is greater than 0. Right now, we will explain it very carefully. If I am having roots minus b plus minus root of d upon 2a, right? Here, see very carefully. If d is greater than 0, that means my value that comes in root is greater than 0. Simple, right? So if the value in d of the value that comes in root, that is the value of d, is greater than 0, right? Now, if it is a perfect square, then we can get a rational number, right? So we can say if d is a perfect square and d is greater than 0, then we can say it can have two real, rational, and unequal roots. Two real, rational, and unequal roots, right? Second, if d is not a perfect square, now that means my under root value will come, right? If something is in root, then it becomes irrational, right? So if I talk about when my d is greater than 0 but not a perfect square, then we have two real, irrational, and unequal roots. Very simple, right? Now let us proceed further. If d is equals to 0, if my d is equals to 0, very simple, we can say if the value of d is 0, so it will be minus b plus minus root of 0 upon 2a. Root of 0 is 0, so minus b upon 2a, right? So we can see that my both roots are minus b upon 2a, right? Now, so we can say if d is equals to 0, then we can simply say that one real and rational root, or we can say both the roots are equal. Both the roots are same, right? Now, if d is less than 0, if d comes in root, very simple. Here, right? If d is less than 0, then we can say the roots are not real. Till now, till your 10th class, you have studied that roots are not real, right? But in 11th class, as you have already studied about complex numbers, so we can say if d is less than 0, means we are getting a negative number in square root. So d is less than 0 means imaginary roots. There comes the part of iota, right? Now, remember one thing. If d is less than 0, right, then we can say my both roots, if d is less than 0, then we can say my both roots, both roots conjugate, are conjugate of each other, right? Conjugate that we have already studied. I hope you remember, everyone. Come on, give me a yes if you remember. Great. Right. Yes. Absolutely correct. If one root is 3 plus iota, other root will be 3 minus iota. Both the roots will be conjugate of each other. Right. I hope this is clear. Okay, come on, everyone. Please take the notes, sir. Great. So now, students, let us proceed further and solve some questions based on nature of roots. Now, remember, first thing, equation must be in standard form, right? I have written the conditions over here for you guys, so that it will be easy for you. Now, describe the nature of roots of 3t square plus 5t is equals to 2. Now, this equation is not in standard form because this is equals to 2. First, we have to make it equal to 0. So, how we can make it equal to 0? We can transpose 2 to the left hand side. So, we can write the equation as 3t square plus 5t minus 2 equal to 0. Now compare it with the standard form. Standard form is ax square plus bx plus c equal to 0. So what is the value of a over here? Value of a is 3, the value of b is 5, and the value of c is minus 2. Remember, we have to consider the negative sign as well, right? So d equals to b square minus 4ac, right? Now what is b? 5. 5 square minus 4. A is 3 and c is minus 2. So if we calculate d comes out to be 49. Now remember, d is a perfect square and d is greater than 0. So it will have two real, unequal and rational roots. First condition is satisfied. Very simple. Right, great. So now let us proceed to the next question. Here, compute for the discriminant. Means what we have to do, we have to find discriminant. First, check whether it is in standard form or not. It is already in standard form. Right now, equal to 0. Now, A is what? 9. B is minus 12. C is 4. I hope you remember it easily. So, B square minus 4 is 12 square minus 12 square. That is 144. Minus 4 into 9 into 4. 144. So, what we can see over here, we can see that D is equals to 0. Now, remember the condition. Let us go to the back slide. D is equals to 0. So, it will have one root and rational root. Or we can say both the roots are same. Right now, one root is written because both the roots are same. I hope that I have told you about the graphs of this, right? Now let us see if I am having the graph of x square. This is also a quadratic equation, y equals to x square, right? So its graph will be something like this because here both the roots are same, 0, right now. So we can write one root, rational root, or we can write both the roots are same. Now I am going to give you a question. I want all of you to solve it. Come on, students. Now, what is the nature of the roots of this equation? Try to solve. Yes, absolutely. First, we have to convert it into standard form. How we are going to do? We are going to write it as h square minus 16 plus 3h equal to 0. We have transposed these two numbers on the left hand side. Now we have to rearrange the numbers. H square plus 3h minus 16 is equals to 0. Right? Now, what is a, b, and c over here? A is equals to 1, b is equals to 3, and c is equals to minus 16, right? So what is d? D is equals to b square minus 4ac. So what is b? That is 3, 3 square minus 4. A is what? 1 and c is what? Minus 16. So b square will be 9 minus. So minus 4 into minus 16. We can keep minus outside and we can multiply 4 with 16. That is minus 64. So we can get it as 9 plus 64. That will be equals to 73. Now, guys, you just tell me what is the condition for this. Here, yes, we have D greater than 0. But D is not a perfect square. So what we are going to get? We are going to get its two roots, right? We are going to have two roots, right? That are unequal and irrational. Not rational roots, unequal and rational roots, right? So guys, that was it for today, right? So now let us just have a quick summary. In today's session, we have discussed about the nature of roots, and nature of roots we can totally calculate it from about discriminant, right? Now, if d is greater than 0 and d is a perfect square, then it can have two real, right, distinct and rational roots. If d is greater than 0 but not a perfect square, so it will have two real, distinct and irrational roots, right? Second condition, if d is equals to 0, it can have two equal and real roots. If d is less than 0, that means our negative sign comes in the root, so we can say it will have imaginary roots and both the roots are conjugate of each other, right? So I hope you enjoyed this session. So that was it for today. Thank you everyone. Have a good day. Take care. Bye bye.